Good morning, everyone. Today we will be presenting our science water rocket project. First, let me explain briefly what a water rocket is. A water rocket is a type of model rocket using water as its reaction mass. The water is forced out by a pressurized gas, typically compressed by air. Like all rocket engines, it operates on the principle of Newton's third law of motion. Water rocket hypotheses typically use one or more plastic soft drink bottles as the rocket's pressure vessel. Our aim for this project is to construct a water rocket model that can reach the maximum flight altitude to flight time. We constructed 4 different water rocket models with different materials to study how the use of different materials will affect the flying altitude. Each model has advantages and disadvantages over each other. We will now present to you our models. Please enjoy our presentation.
Our first model, Model 1, has a 3D printed nose cone, just like all other models. This makes the rather snub-nosed end of the fizzy drinks bottle more aerodynamic. The body of the rocket is made by a 2-liter soda bottle. The base and fins of the rocket are also 3D printed, providing stability during the flight. With 3D printing, the base and fins of the rocket can be combined into one component, hence eliminating the extra weight of tape. With a lighter body, the same reaction force can push the rocket higher. Moreover, with so many 3D printed components, we can ensure that Model 1's weight is balanced and it can fly vertically, hence achieving the highest flight altitude.
I'm SIRI and I will be talking about the Model 2. The Model 2 is quite similar to Model X and Y, which all has a nose that covers the whole bottle, unlike Model 1, which only covers the cap. This can increase the aerodynamics. As for the body of the water rocket, Model 2 will be using the same as all the others, a 2-liter bottle. However, the top will be cut in order to reduce the weight. As for the fins, this time we'll be using a triangular fin, unlike the other, which is curved. And for the materials, we'll only use a little bit of 3D materials, and most of it will be cardboard, as cardboard is quite lightweight. And lastly, instead of using either cardboard or 3D materials, we decided to use both in it. This is because this allows the water rocket to keep its well-balanced form and also be lightweight.
As for our third model, the 3D printed nose of the rocket, the bottle and the cardboard are constructed by the lightest materials out of all the rockets. The 3D printed nose is covered carefully around the bottle as to make the water rocket more smooth and receive less air pressure. The fins of Model X is a curved fin. The fins are constructed by cardboard, as we have found that cardboard-made materials are slightly lighter than the 3D printed ones. Unlike other rockets, even though Model X is the lightest, it is still well balanced and can reach a high flight altitude due to the light weight of it.
As for the fourth model, the water rocket features a 3D printed nose. This makes water rocket more aerodynamic. The body of the rocket is made from a 2-liter soda bottle. The rocket base and fins are made of cardboard, which reduce the weight of the water rocket. Fins are important to ensure smooth flight of the rocket. The fins are thin, which reduce air friction when the water rocket is launched, and also reduce its weight. The base is also made of cardboard and is lighter in weight than a 3D printed base. With so many cardboard parts, we can guarantee that the rocket will take longer to land. So the rocket will spend longer in the air and thus travel farther.
In this project, we hypothesized that Model X will fly the highest and stay in the air for the longest time, since it has the most streamlined shape and the lightest materials. Also, it not only ensures a well-balanced rocket with the 3D printed parts, but also has a shorter body so that it can reach a higher altitude than others. Thanks for watching our project presentation and the LSE News. On behalf of all of us in this group, see you next time.
Start. 2, 1, booster ignition, and liftoff of the Space Shuttle Discovery, returning to the space station, paving the way for future missions beyond. Roll program.